If f prime of x is equal to g prime of x for all of x, then which of the following are true? Okay, so let's take a look at starting at e. If this is true, then we're saying that the antiderivative of f prime gives us the f of x, and antiderivative of g prime gives us g of x. And we cannot say that they're equal because when we antidifferentiate, so this is example here, so if I antidifferentiate this, I'm going to end up with f of x plus c, and if I antidifferentiate the g prime, I end up with g of x plus c. And I'll call that c2. And so these are going to differ by c, some constant. So we cannot say that that's necessarily true. Okay, so we're going to eliminate that. If we take a look at d, it says that the integral of f equals the integral of g, and we account for the plus c with this plus c on the outside. However, we have to remember that if we integrate this, basically f is going to look like this. It's going to look like f of x plus c dx, and then there's going to be f of g, g of x plus c. This is our c2. Okay, because when we antidifferentiate, we're going to end up with these c's. Now, this c could possibly account for that, but it doesn't, because when we antidifferentiate this, we end up with, we'll call the antiderivative of f. I don't know what kind of notation we'll use, but basically we'll end up with f of x dx plus this c becomes, and I'm just going to highlight it here, this c1 is going to become a plus cx. Okay? And we're going to then end up with the integral here, and that's all okay, but the c2 also becomes a cx term, and then we have another plus, c here. Okay, so this plus c does account for that. Okay, so this plus c here, which I'll highlight in blue, would account for that, but it doesn't account for the other two c's here. I'm just going to clean this up a bit. This should be c1x. Okay, and that's because the antiderivative of c1 becomes c1x, antiderivative of c2 becomes c2x. So although the plus c does accommodate this plus c here, okay, so this plus c right there accommodates this plus c here, it doesn't account for these extra plus cx's. So we're going to have to then say that D is, there's a contradiction when it comes to possibility D. Okay, so looking at C then, if we say that the integrals of these are equal, then, well, that's the same issue here with C, except we now no longer have this plus C here, which accounts for this plus C. Okay, so we don't have a plus C that even accounts for that, so we still have the issue in option C, the same problem here, that this C1x and this C2x don't necessarily match, and we also have a plus C that doesn't match. So this option is again not possible. Okay, and this is B that we're talking about. So we antidifferentiate those two. For C now we're talking about the definite integral. So when we talk about the definite integral here, the area underneath the curve from A to B, from here to here, well, the plus c's normally will cancel out when we do that. But again, because we're antidifferentiating an antiderivative, that antiderivative would include this plus c1 here and plus c2 over here. So because of those extra c's that we have, getting to the first antiderivative, to antidifferentiate again, and then to put in our bounds, so we put in our bounds from A to B now, from A to B, those c's don't cancel out. Although now, because it is a definite integral, we don't actually have to worry about this extra plus c. This extra plus c over here will cancel out. The first antiderivative, though, will have these C1s and C2s, which means that when we do the definite integral, that is not going to cancel out with these here. Okay, the area under C1x from a to b does not cancel out with the area under C2x from a to b because those constants aren't necessarily the same. So then C then becomes a non-option. So the answer is A. And let's make sure we understand why the answer is A. Oops. Okay, let's take a look at why the answer is A. And if we take a look at the area under the curve, so we know that f prime and g prime are the same curve. And basically what this statement here is saying, I'm just going to do this in green, this statement here is saying the area under this graph from A to B. Okay, that's the area, that's a definite integral. Well, that area then, so this is f slash g prime of x. Well, the area under the f prime graph is equal to the area under the g prime graph from the same bounds because that curve is exactly the same. So because of that fact, we know that the answer must be A. So that's the only possibility that doesn't have any contradictions.